Alright, let's say they want us to find, let's write directions on top. Find, that says find, a positive and a negative angle that are coterminal with pi over 6. So I need one positive and one negative. So in this problem, I have an angle now measured in radians. I know it's radians because there's no degree symbol and it has the pi symbol. So my given angle is pi over 6. Well, I need one that's positive, so I can just do one positive rotation. So pi over 6 plus 1 times 2 pi is going to give me my new angle, my coterminal angle. Well, I just multiply. 1 times 2 pi is how much, boss? Now, the difficulties with coterminal angles of radians is just the fraction part. So I cannot add this. I cannot say the answer is 3 pi over 6. I have to have a common denominator, so I'm going to make this a fraction by putting it over 1. And then I have a denominator of 6, so my common denominator is 6. So now I have 1 pi over 6 plus multiply across, I have 12 pi over 6. And then we just add the numerators, class. 1 plus 12 is 13. So my answer is 13 pi over 6. Let's draw a picture to help us make sure we understand what's going on. One vocabulary word I may have forgotten. Everyone say standard position. It always starts in standard position. That's between quadrants 1 and 4. Yesterday we learned how to move around on the coordinate plane in degrees. So let's practice degrees. Class, this is 0 degrees. If I move up here, this would be 90 degrees because it's a right angle, right? 0, 90. How much is this one? 180. Down here? 270. And if I come back up here, 360. So that's degrees. But let's do this now in radians. If I don't move anywhere, we normally don't say 0 pi, but it gives you an idea. And a full rotation in radians is how much, class? Is 2 pi. Now, if I don't do a full rotation, I only do half of a rotation. Class, what's half of 2 pi? What's half of pi? So we call this pi over 2. 90 plus 180 gives me 270, so pi over 2 plus pi, or 2 pi over 2, equals 3 pi over 2. Now, many of you are tempted to, well, we have formulas to go back from radians to degrees, but why not just stay in radians? So what is pi over 6? Well, if you think about it, pi over 6 is like 1 over 6. So if I put in my calculator 1 over 6, this is essentially 0.17 pi. And this is like 0.5 pi. So is 0.17 less than or more than 0.5 pi. It's less than. It's going to be in quadrant 1. So here is my terminal side, pi over 6. My angle, pi over 6, theta. From standard position we learned yesterday, positive degrees go counterclockwise. Class, if I'm adding 2 pi, which direction should I go from here? Clockwise or counterclockwise? So if I do a full rotation, right, that's adding 2 pi, this will get me 13 pi over 6. Pi over 6 and 13 pi over 6 are coterminal angles. They're coterminal angles because they end up in the same position. Let's do our negative. Pi over 6 plus a negative 1 times 2 pi. So this gives me pi over 6 minus 2 pi. I can make anything a fraction by putting over 1. Need a common denominator. Can I make it 3 over 3? Would that work? No, that won't work. Why did I write that? So I get pi over 6, or 1 pi over 6, minus 12 pi over 6. This gives you what, class? Negative 11 pi over 6. Now my negative sign, kind of high, but it's normally in line with the fraction. It's saying the whole expression is negative. In this case, it does not matter where our negative goes for now. So our answer of a negative 11 pi over 6, think about it. We're trying to find angles that are coterminal with pi over 6. And that ends up in quadrant 1. If I go in this direction, positive degrees, I end up in the same position, back in quadrant 1. Class, a negative angle goes in which direction? So if I go negative 2 pi, I start here, right? And I go clockwise. That's one full rotation. That's a negative 2 pi. I get an answer of negative 11 pi over 6. Negative 11 pi over 6 and pi over 6 are coterminal angles. The only difference is this one is negative. And so we did coterminal angles in one positive, one negative, and radians.